Yes, good morning to all. Am I audible? Yes, just let me know in the chat box. Yes, roll number 9, Omkar. Yes, am I audible? Okay. So I hope the screen is visible. Okay. So in the last class we discussed about the pipelining techniques. Okay. So pipelining technique that makes the program execution faster. Okay. The execution, the speed of the instruction execution, it makes faster. Speed of instruction execution, it makes faster. Okay, so that is the main use of pipelining technique. So use the faster circuit technology. Use the circuit technology, means faster circuit, like the cache memory, okay, or main memory, to build the processor and the main memory, and arrange the hardware so that more than one operation can be performed at the same time. We need to uh, arrange the hardware so that the more than one operation that can be performed at the same time, so that is, it makes execution faster. Okay. So it is like for one general example. Okay. Suppose if you consider a, this is a theater hall. Okay. So here, like this is the one door, this is one more door, this is one more door, and here screen is there. Okay. So if there are if there are 250 people, if they occupy here in a theater. Okay. And suppose if there is only one door. Okay, if suppose if there is only one door, then it takes more time, right? It takes more time to get inside or to get out from the theater. Okay. Suppose if the parallelly, if there are, if the people, if they use the multiple doors. Okay. Then means at the same time, the few people, like 50 people will exit from here, 50 from here, 50 here. Means parallelly, they, within a very short time, they can disperse. Okay. Within a short time. Means here we rearranged the, like, doors. Initially it was only one door was there. Okay. Now there are four. One, two, three, four. So it takes less time. So in the same way here, arrange the hardware. Okay, arrange the hardware so that more than one operation can be performed at the same time. More than one operation means multiple operation. So the number of operation performed per second is increased even though the elapsed time needed to perform the one operation is not changed. Means the time required for the operation is not changed. Required for the operation or task, that is not changed. Okay, it will be same. Suppose if you are taking after the lecture, so after your lecture if you are taking a 10 minutes break, so this you are not changing. Okay, this you are not changing. The this particular time will not change. And also we discussed a simple example of there are four loads are there, load of cloths, and each load need to complete the three tasks, that is washing the cloths, dry the cloths, and folding. Okay, so it takes 30 minutes to wash for one load, then 40 minutes for drying and 20 minutes, so total how much? 90 minutes will take for one load. For one load of cloth it is taking 90 minutes, right? Then for four load how much? 360 minutes it will take. Okay, means here it is some general example. एक लोड के लिए कितना टाइम हो रहा है? 90 मिनट फॉर फोर लोड 360 मिनट मीन्स 6 आवर. 6 आवर it will take to complete the this particular the four load completion. Laundry example, there are four loads are there, you have to complete the task. For each load there is a three task is there, 1 2 3. Okay, and each task is specified with some time. Okay, कपड़े वॉश करने के लिए 30 मिनट, ड्राई करने के लिए 40 मिनट, फोल्डिंग के लिए 20 मिनट, ऐसे टाइम फिक्स है. तो सपोज इफ वी यूज द सीक्वेंशियल ऑपरेशन, sequentially process if we do, for A it takes 1.5 hour, for B load it takes 1.5 hour, for third ऐसे एक के बाद एक हम कंप्लीट करते गए तो कितना होता है? 6 आवर्स. वी आर टेकिंग 6 आवर्स to complete four load of cloth, right? So means in the sequential process it takes more time, so that's why we are going for the a pipelined approach. So in pipelined approach we are executing the task parallelly. Okay, so like initially in the A load, so here we are providing the A load to the washing machine, then at the same time means this particular time, then next this load will move to drying machine. So when it is shifted to drying machine, this load A, okay, this will be empty. Means empty means it is not utilized. This particular resource is not utilized. तो क्या होता है? एक खाली है. There is no use or usage of this particular washing machine during this time. Okay. So B will utilize that particular, because B is in the waiting. The next is B is in the queue, and he will utilize at the same time. Okay, so means you during this particular time both these resources are utilized, and next during this particular time here A load is in the folding stage because this operation is completed. Then B B load will be in the drying machine, and now the even washing machine is available, so here the load C will come. So during this particular time all the three resources What are the three resources? Like this washing machine, okay, then drying machine, then folding table, okay. Folding table. So all these three are utilized at this particular time. Means here parallelly at the same time we are doing this work, okay. मीन्स यहाँ कितना होता है लाइक अभी 70 मिनट्स, ये सपोज 6 बजे हमने काम शुरू किया, तो यहाँ कितना है 7-10 बजे, सपोज 7 7 10, ओके, इन 7 10 you can means 7:10 p.m. with respect to time, 7:10 p.m. को you can see uh, these particular resources are utilized parallelly, okay, all the three resources. Okay, here. So the main advantage of the this pipeline is it does not help latency of the single task, okay. Means it will take same time for washing machine, it is take 30 minutes only for all the load, okay. So it does not help in reducing the latency of a single task, but it helps only in the throughput of entire workload. Throughput means here it will take 3 hours 50 minutes I think. Here you can see 30 40 कितना होता है, 160 and 50, 210 minutes it will take, okay. So 3 hours 30 minutes, 3 hours 30 minutes it will take when we use the pipeline technique. Means we are completing all four loads of cloth in how many, 3 hours 3 minutes. So that is pipelining the multiple tasks operating simultaneously using the different resources. Here multiple tasks are operating simultaneously, using the different resources, different resources, okay, different resources. So the idea of pipelining in the in computer, same we if we apply. So here the instruction execution, it is divided into two stages, like the fetching and execution. So if the particular one instruction, okay, I1 is the one instruction, so this instruction is fetched and executed. So this completes one instruction. The second instruction, fetching and executing, then third instruction, fetching and executing. So ऐसे कितने हुए यहाँ, three instructions. So for three instruction, if we take a if we consider one clock cycle for each operation, one clock cycle, okay, then here how many, total 6 clock cycle it will take. That is sequential approach. Suppose if we use the same in a pipeline form, pipeline concept, executing the instructions simultaneously. So the instruction I1 during the clock cycle 1, so the first is fetching operation, fetching, because see this is called as a two-stage pipeline. Why this is two-stage pipeline? Because two-stage pipeline, two-stage क्यों है? Because means here we are considered to execute one instruction, there are two different units are there. One is instruction fetch unit and another is execution unit, okay. So here you can see there are three, in this particular example there are three resources are there. This is one resource, second resource, third resource. So this we can call it a three-stage pipeline. Means to complete one load it has to pass three stages, right? ये तीनों स्टेज पास करना पड़ेगा. One load of cloth it has to pass three stages. So that is three stages. So here in terms of computer we just it is simple example for two-stage pipeline. So the instruction it has to pass two stages. Okay. So during the clock cycle 1 the first instruction is fetched. During the clock cycle 2 the first instruction is in the execution stage unit, second stage. At the same time this unit is idle. This fetch unit is there, no? This is idle, means it is not working. So here we are fetching the second instruction. Then during the clock cycle 3 the second instruction is in the execution stage. At the same time third instruction is fetched. So next in the fourth cycle third instruction is executed. Okay. So you can observe here in the two-stage pipeline at the end of the clock cycle 2 at the end of clock cycle 2 one instruction is executed. One particular instruction is executed. Okay. Then after that second clock cycle in every clock cycle one new instruction is executed. One new instruction is executed. Like in the third clock cycle second instruction is executed. In the fourth clock cycle third instruction is executed. So likewise in the fifth clock cycle one more instruction is executed. Like so here it is taking the 4 clock cycle for 3 instructions. In sequential process it was 6 clock cycle. Okay. So these are all concepts we discussed yesterday. Suppose if we consider a 4-stage pipeline. Okay. 4-stage pipeline. Instruction I1, I2, I3. Okay, there are 3 instructions are there, and here in this here we have considered 4-stage pipeline. 4-stage pipeline. 4-stage pipeline means what? There are to execute one instruction. There are 4 stages are there. One is fetching, decoding operation, execution stage, and write result. So likewise there are 4 stages are there to execute one instruction. Okay. So here we'll see with respect to the clock cycle 1, 2, 3, 4, 5, 6, 7. Okay. So now first one instruction which stage now the first is instruction fetch IF1. Okay, during the clock cycle 1. During the clock cycle 2 what happens? Okay, during the clock cycle 2 this will go in what is the second one? Decoding, right? Instruction decoding. In first instruction is in the decoding stage. At the same time no, this second instruction is in the fetch stage. IF2 means instruction fetch, second instruction. Now in the third clock cycle, third cycle comes a stage execution. So instruction execution 1, first instruction is in the execution stage. At the same time this will go to the decoding stage. Second instruction will go to the decoding and third instruction will be fetched. Third instruction will be fetched. Now during the clock cycle 4 Last fourth stage कौन सा है? Write result. Write result means instruction in the this particular stage, write stage, and at the same time, at the same clock cycle, this particular second instruction, ये क्या होता है? Instruction execution stage को जाता है. Here third instruction will go to decoding stage. Okay, so for three instructions, okay, so there are three instructions are there. Okay, now so here you can observe at the end of fourth clock cycle, one instruction is executed now. Okay, now you can see in the during the clock cycle 5. Okay, ये तो हो गया अभी. First instruction is completed successfully. Second instruction, it will go to the which right stage. Then this one will go to the execution stage. Okay, here we are consider only three instructions. So okay, now you can see in the clock cycle 5, second instruction is executed. यहाँ first instruction execute हुआ, यहाँ second instruction execute हुआ. Now in the clock cycle 6, okay, third instruction will be executed. So that is in the third instruction will be executed. So how many it is taking? The six clock cycle in four stage pipeline. Okay, I hope you are getting. Okay, so if it is four stage means, like here we are consider each stage takes one clock cycle time, one clock cycle. Okay, so at the end of the fourth clock cycle, why fourth clock cycle? Because here one instruction it has to cross four stages. This we call it as pipeline stages. Pipeline stages. So after the fourth clock cycle, in every clock cycle, a new instruction is executing. Okay. Suppose if the same approach for three instruction, and there are four stages, and if we use the sequential process, if we use the sequential execution of instruction, then it will take 3 into 4, how much? 12 clock cycle it will take. Means if we use sequential approach, तो यहाँ कितना हो रहा है हमारा? So it is taking the 6 clock cycle. Okay, so in this way you have to understand this particular topic. Okay, so just for a homework, what you do, take four stage you can four stage pipeline, instruction fetch, instruction decode, instruction execution, plus instruction write result. Okay, there are four stage pipeline is there. Take five instructions. Okay, and each instruction take each stage take one clock cycle time. So now you have to calculate for 5 instruction using the pipelining technique, how much it times it take, how much clock cycle to execute the 5 instruction. Okay, as a homework you do it. Okay, I hope you understood this question. There are four stages are there. I have given 5 instructions. You can I1, I2, I3. There are 5 instructions are there, and draw a pipeline like this. Okay, and you have to, like, for 3 instructions it is taking the 6 clock cycle. Okay, so in this way for 5 instruction you calculate how much time it takes. Okay.